Okay, good morning everybody. Today we are going to discuss a new topic that is called, you see here, it is written as pulse code modulation. PCM stands for pulse code modulation. So in this process, what will happen? In this process, you have your analog data. I just write here analog data, and that particular data is converted to the digital signal. Okay, so the process of converting analog data into digital signal, that is called pulse code modulation. So in this case, you see the main components are, first we need a transmitter denoted by suppose TX. After that we need a transmission path, and the last but not the least we need a receiver. Simple. For data communication we need these three things: transmitter, transmission path through which your message signal actually travel from transmitter to receiver end, and receiver is nothing but the point by which you can pick your main message signal. Clear? So in this process, for pulse code modulation, you see I just draw some block diagrams here. This is for transmitter purpose, this one for transmitter. Okay, this one for transmitter, this is denoted by TX. In this case, the main components are sampler, quantizer and encoder. But before that, suppose this is my message signal. This message signal is in the form of analog. That means the nature of message signal is analog. That particular analog signal first go through some low pass filter. LPF stands for what? Low pass filter. Clear? Then the output of this low pass filter pass through the part that is called sampler. Okay, so first your message signal pass through some low pass filter, and the output of low pass filter acting as an input of a sampler. Okay, so after sampling, the next part we go for quantizer, and the last one is your encoder part. So whenever your message signal coming out from low pass filter, after sampling it will look like, you see, just like discrete in nature, like this. Okay, here you see this is my message signal, and after sampling it looks like this type. That means here infinite number of amplitudes are there. These are nothing but infinite numbers, but it has a certain value. That means from 0 to a maximum level. Suppose this is my max value. Clear? So this sampling message, after sampling, it will go through this quantizer. The next block is our quantizer, and after quantization it looks like a fixed, you see, finite number of amplitudes are there. That means what is the function of quantizer? The function of quantizer is to convert infinite number of amplitudes to the finite number of amplitudes. Clear? Then we move on our encoder part. Simple, the function of encoder is nothing but encoding process. After encoding, you will get our PCM, pulse code modulation signal. Clear? Then next stage we go for what? Transmission path. So this is my transmission path, and in this path what will happen? That particular PCM signal go through some regenerative repeater. What is the function of regenerative repeater? The function of regenerative repeater is to low or delete that particular noise or distortion from your main message signal. Okay, so in our transmission path, in certain instant of point, we have to use these regenerative repeaters. Clear? So this PCM signal go through this regenerative repeater, and finally you see will get a regenerative PCM signal. So this is all about my transmission path. Then we move on our receiver part. This is my receiver portion. In this receiver part, what will happen? That particular regenerative PCM signal go through some regeneration circuit, and then the output of that particular regeneration circuit is acting as an input of your decoder, and the output of decoder is going through some reconstruction filter, and finally you will go to your destination. Okay, this is your final stage. And you see two different things. That means in transmitter part, this quantizer and encoder, these two block acting as a ADC. That means analog to digital conversion. And in case of receiver end, here this regeneration circuit as well as decoder and reconstruction filter acting as a DAC, digital to analog converter. Okay, and another thing is that here whatever we use this sampler actually follow the sampling theorem. That particular theorem is nothing but Fs greater than equal to twice Fm. Here Fs is nothing but sampling frequency, and Fm stands for what? Highest frequency of message signal. So this is all about pulse code modulation. Okay, thank you.